Okay, let's dive right into an example. So in this example, it says a chemist weighs out enough aluminum chloride to have 0.597 moles of aluminum chloride. The chemist needs at least how many moles of barium hydroxide to react with 0.597 moles of aluminum chloride? Now, if you watched part one of this video, you actually saw this problem before, but I didn't show you how it was solved. We did a lot of the work there with mental math, and this was one that was difficult to do with mental math, but I did give you the answer. So let's see how we would solve it using this process. So we're going from our moles of given to our moles of find, and we're going to use the coefficients in the balanced chemical equation. But first step is to make sure that the equation is checked, is balanced correctly, and it is. So if you were to tally up all the aluminums, chlorines, bariums, oxygens, and hydrogens on the reactant side and do the same thing on the product side, you would see you have the same number of each type of atom on both sides. So this one's balanced. So now we're going to look for our given. Our given is aluminum chloride, and our find is barium hydroxide. So that gives us the mole ratio. So if we want to convert from moles of aluminum chloride to moles of barium hydroxide, we're going to use the 2 moles of aluminum chloride is equivalent to 3 moles of barium hydroxide, or the 2 to 3 mole ratio. And again, I'm just getting that information, as you can see, straight from the coefficients in the balanced chemical equation. Okay, now for my setup. My setup is always the same, and you guys have seen this for about a week now. So at this point, I'm expecting you guys to be able to do this without too much support or assistance. But remember, we always start by writing our given over 1, and then we multiply it by our conversion factor. Now, the conversion factor is going to come from the coefficients in the balanced chemical equation. So since my given is moles of aluminum chloride and I want to get rid of it, in my conversion factor fraction, I need to put moles of aluminum chloride on the bottom. The part of the conversion factor that has moles of aluminum chloride says 2 moles of aluminum chloride. So the 2 moles of aluminum chloride goes on the bottom so that those units can cancel out. Then on top, I'll put what's left, which is the 3 moles of barium hydroxide. And that should be a 2 there, by the way, not a 3. But at any rate, we go ahead and do our math, and we get that the 0.896 moles of barium hydroxide. Okay, so I went ahead and corrected the chemical formulas for the barium hydroxide. But our final answer here is 0.896 moles of barium hydroxide, and that's how we got that answer. Let's look at another example. So in this example, we're asked how many moles of nitrogen do you need to react with 1.38 moles of hydrogen? So we have a chemical equation here. First thing we need to do before we get started in solving is make sure this is balanced, because if it's not balanced, we don't have our recipe. So we won't be able to know, according to the recipe, how many moles of nitrogen we would need for a certain amount of hydrogen and vice versa. So let's go ahead and check this. And if you check this reaction, you see it's not balanced. And that's because it's, on the reactant side, for example, you have 2 nitrogens, but on the product side, you only have 1. You have 2 hydrogens on the reactant side, but 3 on the product side. So it's not balanced. So what we're going to do is we're going to balance it by changing the coefficients to the appropriate ones. And if you're not sure how to balance this equation, I will link in the extra help how to balance this. This is a skill that you just need to know and be able to do, but we won't cover it here. But there's a video that will show you how to balance this exact equation. So we go ahead and we change the coefficients so we can balance it. So a 3 goes in front of H2 and a 2 goes in front of NH3. And now the equation is balanced. So we're good. All right, we can go ahead and solve now. So our given here, we're given 1.38 moles of H2. And we're trying to find the moles of N2. So to convert from moles of H2 to moles of N2, we're going to use these coefficients to make our conversion factor. So the ratio is 1 mole of N2 to 3 moles of H2, or you can say 1 mole of N2 is equivalent to 3 moles of H2. Remember, we use this information to make our conversion factor fraction when we're solving. All right, in terms of the math, what does it look like? So we're going to take our given, which is 1.3 moles of H2 over 1, and then we're going to multiply it by this conversion factor fraction. So since I'm starting with moles of H2 and I want to get rid of it, in this second fraction here, moles of H2 goes on the bottom. And that would be 3 moles of H2 because I get that from my conversion factor. So that goes on the bottom so the moles of H2 can cancel. And then the 1 mole of N2 goes on top. So the math here will be 1.38 divided by 3, and that gives me 0.46 moles of N2. All right, next example. How many moles of C3H8 do you need to react to make 0.455 moles of CO2? All right, what do you think the first step is? Right, first thing we need to do is check to make sure the reaction is balanced, because if it's not balanced, we don't have our recipe, we won't know what the ratios are. So I go ahead and check this and see that it is not balanced. And you can tell that the number of each type of atom is not the same on both sides of the reaction arrow. So I need to change the coefficient. And these are the coefficients that actually balance out the equation. So now this equation is balanced. All right, now we can go to our equation and our chemical equation, look for the given. So we're given 0.455 moles of CO2. So there goes my CO2 in the reaction. And I'm trying to find C3H8. So there goes the C3H8 in the reaction. So I look in the balanced chemical equation so I can get my mole ratios. Now I can go ahead and proceed to converting between moles of CO2 to moles of C3H8. And my mole ratio here is 1 mole of C3H8 to 3 moles of CO2. Again, those come from the coefficients. This information I will use in my conversion factor fraction when I'm solving. So start it off, I'm going to take the 0.455 moles of CO2, put it over 1, so my given, what I'm given, over 1. And then in the for the conversion factor fraction, I put the 3 moles of CO2 on the bottom since I want moles of CO2 to go cancel out, and the 1 mole of C3H8 goes on top since I want to keep that. And when I do my math here, this is 0.455 divided by 3, I get 0.152 moles of C3H8.